Welcome to Delegating to Components. In this video, we're going to start fleshing out the architecture of our tank game and really setting ourselves up to win. So I'll see you in there. Okay, so let's talk about our iterative cycle just to get a handle on where we are. We've kind of been around this once, and we're going to have another look at the tank now in a bit more detail. So this is our aiming architecture. I'm sorry I can't build this up bit by bit, but it's a limitation of Google Slides. So how are we going to do this? Well, let's start at the top. The tank is going to be possessed by one of two things, either a tank AI controller or a tank player controller, i.e. us at the keyboard or trackpad. And either of those controllers, depending on which one is possessing the tank, is going to send messages to the tank. So in the case of the AI controller, it's going to send a message that's going to say something like aim at the player. And in the case of the tank player, it's going to aim at the crosshair. Although there's a bit of a subtlety there, of course, because the crosshair is in 2D space, and if you project from the camera through the crosshair to the world, then you're talking about a 3D space. So we'll deal with that when we get to it, but we're basically saying aim at where this crosshair is pointing at in the world. And then the tank is going to receive that and say, well, okay, that's fine, but I'm going to delegate that functionality down to my tank aiming component. Why bother with that? Well, it's simple information hiding. The tank player controller, the tank AI controller, anything outside of the tank, don't care how the tank aims. They're just saying to it, please aim at something. And the tank, we're saying, is complicated enough to need to break its functionality into components. It's going to have a tank aiming component. It's also going to have a tank movement component. So it's going to simply pass that method straight through to the tank aiming component, which is going to do some processing on it, including ballistic calculations, etc. And then, by the way, by ballistic calculations, I mean a reverse calculation of where it needs to aim right now in order to hit the desired target. Or more specifically, how fast it needs to fire in order to hit that target, the projectile velocity. Once it's worked all that out, it's going to then raise an event in Blueprint. Why in Blueprint? Well, because what's actually finally going to happen is we're going to rotate the turret and we're going to elevate the barrel. And those two things, the turret and the barrel, are assets, and they want to be soft referenced in Blueprint so that should we want to make a change to those assets, they're not hard-coded by path, by file name in the C++. So we make all our asset references in Blueprint. So finally, this long line of code will emerge in the Blueprint, and that will do the final bit of work. All right, so for any of this to work, we're going to go through it bit by bit, nice and slowly. The first thing we're going to need is a tank player controller in C++. So if you remember in our project, we already have, of course, in the tank folder, a tank player controller blueprint. And it does very little at the moment. It just sets up the user interface, or the player user interface. But it's currently based on the player controller class. What we want to do is we want to specialize this ourselves and make ourselves our own tank player controller. So that's going to be your challenge. It's just to make sure that you know how to make your own classes. So before I put you into a challenge, I want to remind you how to reparent a class. You click on Class Settings, and then you can choose your parent class here. So here's the challenge for you. Relatively simple. I want you to create a tank player controller C++ class. You'll need to compile that class first, then you can reparent the tank player controller blueprint onto your new class. By the way, the tank player controller is going to inherit from player controller. So that's what you're going to be inheriting from when you create it. You're going to have to find your way around the menus to do this. We've done this before, so it should be a good bit of revision for you. And basically, good luck. So see if you can do that. The class doesn't need to do anything yet. You just want you to create it and reparent the blueprint. Okay, welcome back. So here we are in Unreal. I am going to go to my C++ classes. We're going to add a new C++ class. And we're going to have to ask ourselves what type of class this is. Well, here you have a player controller option. So the reason for choosing these things is it prevents you from having to write all of the header code in the header file yourself. By doing this, it's basically writing a bunch of that for you. So we choose the player controller style. We're going to call it tank player controller, as we're specializing a player controller for a tank. There's also the concept here, by the way, of public and private in terms of the where it stores these things in terms of directories. Click the buttons and see what it does. If you click private, then both of these methods go into a private folder. Both the header file, rather, and the C++ file go into a private subfolder of BattleTank. If you click public, then the header file is left out in a public folder. So you're really asking yourself the question, is this thing going to be called from the outside? But there is no outside here. You know, we're just a tank game. We're not multi-module here. This is just a single game. So some projects decide to separate their files into public and private for simplicity. I'm just going to do this just so we can get used to it. What we're going to do for the whole project is just always click public. And then all that's going to do is mean that all our header files will be in a folder called public, and all our C++ folders will be in a subfolder called private. So let's go ahead and create that tank player controller class now. Doesn't matter, by the way, if you didn't choose public or private. I've never brought it up before. Didn't expect you to. We can move our classes into these required subdirectories in a little bit. But for now, let's just let this happen, and we'll check our header file, and then we will carry on. Because one of the first things we're going to need to do once this class exists is make ourselves a getter which can get the controlled tank. So that'll be the first method I'll be writing. Let's go and have a look at the disk while we wait for this for a second, by the way. Let's have a look at source, battle tank, and now you can see we have these, the build, the game mode, etc. These have all come as default, and then you've got this concept of private, which now has our player controller CPP in it, and public, which has the header file. So all that public button has done has said that I want it separated into this type of subfolder. Great. Okay, so now we have what? Tank player controller.h I'm looking for. What is it written for us? It's included game framework player controller.h and tank player controller generated.h. That's always there. That's all fine. And it's created us a new class called a tank player controller based on a player controller. That's all fine. So let's make ourselves a public getter as a start. So public, and it's going to be get controlled tank. So we're going to return a pointer to a tank. Now, of course, it doesn't know what a tank is, so we're going to need to hash include the tank. It needs to go above the generated.h. The generated.h must be the last include, all right? So just remember that. It's just a quirk of the Unreal header tool. So we're going to hash include tank.h. Otherwise, this a tank pointer will not be a recognized type. The method's going to be get controlled tank, and it's going to be const. It's not going to change any future member variables of this class, right? Being a getter, that makes sense. So let's try and see. Oh, hang on, am I missing something here? A tank? No, I think that's good. Let's see if we can implement this using the Visual Studio create definition method. If you're in Xcode, you see it's failed, so don't worry. I'm going to just go and do it manually, as you would have to do if you were in Xcode. So in Xcode or Visual Studio, you're over in the CPP. You have to, of course, paste that in, but there's some syntactic noise we need to add, of course, over in the C++ file. We need to get the name of the class and put a colon in to fully qualify the class name. So what we have is a tank pointer, a tank player controller, colon get controlled tank, const, we keep the same signature, and then we need our curly braces to give us the implementation. So what do we do? How do we get the control tank? Why are we getting the control tank in the first place? Let's go back to our architecture. The tank player controller is going to need to know what tank it is controlling. So we're going to ask the tank player controller, what tank are you controlling? All right, so get control tank is going to work like this. We get pawn from the tank player controller's perspective. And what that should do is return the pawn that the player controller is currently possessing. That's all happening because our player controller class is based on this player controller here. So get pawn should return the pawn. The tank is a specialization of the pawn. So what we're going to do is we're going to cast to type a tank that pawn. Okay, like so. And then that's the value we're going to be returning. So that's what get controlled tank should be doing for us. All right, we better check it works. So we better have a begin play, I think. Well, let's just check it compiles to start with before we check it works. In fact, we could make it a blueprint event and check it works by printing to the screen from blueprint. That's something we haven't done before. I think we'll do that to finish off the video. So bear with me a second. The compiler's failed. Now, the reason it's failed is because we don't yet have a tank.h, and that's because we don't yet have a tank.c++. That's fine. Remember that our tank blueprint is currently based on pawn. So let's go ahead and quickly make ourselves a tank C++ file. It's going to be almost the same process we just did a moment ago, so I won't challenge you to do it, but you're welcome to pause and do it yourself if you want. We're going to make a class based on a pawn. We're going to call it tank. I'm going to leave it selected as public, which will stay the default now, by the way. And again, let me show you what that does. It means that we now have a tank.h in the public folder and a tank.cpp in the private folder. Okay, so we now have a tank C++ class. I'm going to reparent the pawn by going to class settings and set this to tank. And while we're here, we're also going to reparent the tank player controller onto tank player controller, which I missed previously. Let's compile both of these blueprints. And now let's go ahead and compile the C++. So I think now that it's compiled, rather than proving this works right now and making this video too long, I'm just going to leave things as they are, recap what we've done for you briefly, and then in the next video we'll start logging out and looking and making sure we understand what's going on. So what we've done is we've made a tank player controller C++ class. We have given ourselves a getControlTank method, which should return the tank that is being possessed when we call it. So we're going to need a way of calling it, which we will do in the next video. So congratulations getting this far. I'm just going to leave my code on the screen for you, the relevant code, which is mainly the tank player controller.h, which you need to know is just that. And then the tank player controller.cpp is just that. Okay, fantastic. I'll see you soon.